So before I get too far into this, here are my givens. Here's my goal. What am I trying to prove? What's the objective here? And I got my diagram. Before I start writing out the proof, let's go ahead and put some marks on the diagram to show what we know or what we can quickly find out. My 1 and 3 being congruent is given. So I'm going to make a single arc in here and a single arc in here to show that those two guys are given as congruent. L is parallel to M. What things does that tell me? If N and P are parallel? How about L and M? These two. If these two are parallel, then what kind of angles are 1 and 2? Right, and they would be congruent, right? By the corresponding angles. So I'm going to put another single arc in 2. Now, just ignore all of this for a second. Just look at my diagram. 1, 3, and 2 all have the same number of arcs in them. That means they're all the same measurement. Kind of relates back to our warm-up today. So I know that 1 and 3 are congruent. I just said that 1 and 2 are congruent. Are 2 and 3 congruent? Yeah. 1, they're marked congruent because they both have 1 arc. 2, transitive, right? So let's go back to looking at the whole package. Do I have enough information now to say that these two lines are parallel?
Yes.
What rule? The rule of parallelism. Not quite. Well, what kind of angles? What kind of angles are 2 and 3? And there's a rule that we had that said that. Yeah, the converse of it. The original one says if the lines are parallel, like L and M are, then the alternate exteriors are congruent. The converse says, hey, if you can show me those angles are congruent first, then you can conclude, hey, those lines must be parallel. And that's what we're doing with this proof. I've actually got enough information marked. I just got to write it all down now. Statements, reasons. Initial statement, L is parallel to M because it's given. I'm not even going to write my other given yet because I immediately want to remember, hey, that means 1 and 2 are congruent because of the corresponding angles postulate. Now I'll write my other given down. And that was that angle 1 is congruent to angle 3. Given. And then we just talked about the idea that if this is true, and this is true, or as I've marked it, 1, 2, and 3 all have the same number of marks, therefore they're all the same. Or I can use transitive to combine those. I can say, hey, angle 2 is congruent to angle 3 by the transitive property of congruence. I could also say substitution. It's kind of a coin toss which one you prefer. We'll pause there, let everybody get caught up for a second before we write our last steps. Step, the S being in parentheses in case we only have one to go. And now I'm looking, my goal was to say the two lines are parallel. I've got, if I ignore line L, I've just established that the alternate exteriors are congruent. That's enough to lead to the next step. If I look back at my map, if you will, of where I can go and how to get there, one of the ways to get into lines being parallel is to show that the alternate exteriors are congruent first. There's a path that connects those ideas. Oops, just need the one page. So I can use that here. I'll go ahead and say N is parallel to P by the converse of alternate exterior angles. And that is what I set out to prove. I'm I'm also going to underline converse. Remember, if the conclusion is that the lines are parallel, if you make the statement that they're parallel, you're using the converse. If it comes out of them being parallel, it's the original conditional statement. It's the original theorem or postulate we've talked about. And that's one of the most common mistakes here. Students get those backwards. Or they just assume, well, hey, it had to deal with alternate exterior angles, so that's what I'll write down. This is one of those big tripping points you kind of want to avoid. You know? Other thoughts? Yeah. That's a good thought.